Hi, here we are with Mr. John Franks.
Yes.
You're the CEO of Chord Electronics.
Yes.
Okay, it's a pleasure to stay here with.
Thank you.
In the Chord company profile, we read that you come from the aviation industry.
Yes.
We would like to know, how did you make the transition from from aviation to
Okay.
audio, which seems
All right.
kind
Well,
of peculiar, and how did the aviation in engineering culture has influenced your
philosophy.
philosophy?
Yeah, I understand. Okay. Um, as a young engineer working in the avionics for, which is electronics for aircraft, um, I would often be asked, "Oh, can I make an amplifier?" Because it was a generational thing. People were making amplifiers with transistors,
Mhm.
and an engineer who liked music, I gravitated towards that. So I always was very happy to um, uh, make amplifiers, and it's something that I've always done.
Okay.
And I think the as an avionics engineer, you're developing technologies that never existed before.
Mhm.
And invariably, you could be working on a black box, and maybe the power supply in the black box, suddenly the air ministry would change the specification,
Okay.
and there would be more requirement for more digital cards and less space for the analog. So in avionics, you're driven to use very advanced technologies. So I was using planar magnetics and FET switching 20 years before it became really
Usual, yeah.
usual. So I had that knowledge, but I also had this electro hobby of making amplifiers for me and my buddies.
Yeah.
And so I was able to bring that technology into my amplifier designs, but also the philosophy that you get when you're making electronics for aircraft is that every joint that is soldered,
Mhm.
every component must be the right component, um, because you're making products that uh, people's lives are very dependent on.
Yeah.
So you make beautiful electronics. So I always wanted to bring the idea of making beautiful electronics, but into audio.
Into audio.
So that is really what I've been able to do.
And we're talking about which years when you started?
Oh, I was I think I first exhibited an amplifier around 1982.
82.
But that is the year that I left avionics and I went into industry. I decided to change my direction, and I became a manager in a company called ASIC, which is a Hong Kong-based company.
Mhm.
And um, uh, very soon I was able to graduate within that company, and I ended up a director of that
Okay.
company. And the company was growing very rapidly. But every year, um, because I wasn't working in the design field, I would get some amplifier prototype that I've been working on, and I would take it out of the drawer and start working on it as a hobby. Um, so I did this, for a number of years, about 10 years in total, and uh, uh, I decided that I could bring forward a technology. Uh, Originally, the power devices that I was using were costing, each power device was costing about £400.
Okay.
And this is going back 40 years. So they were very expensive.
Yeah.
But so I couldn't realize a commercial product. But over the 10-year period, the price of MOSFETs was falling.
Yeah. Yeah.
And I could realize my first product. So after 10 years in the industry, um, I done quite well. I became a director of Aztec, and then a director of AT&T, and then a director of Raytheon.
Mhm.
So I had some credibility, but I decided that I wanted to start again, just go back to my engineering roots. But the problem that I had was that what would happen if it didn't work out? And so I spoke around to a couple of hunting companies.
Yeah.
Except with your credibility,
Mhm.
you wouldn't have any problem to go back into industry if I needed to. So with that, I realized that I could take the risk, and I started just very simply making amplifiers for the world,
Yeah.
but in a very small way. So I would build the first two. I built two. I sold those and made five. So I was able to start the company without any big financial risk or
Risk. Yeah. Yeah.
investment.
Yeah.
You know, because I'd been quite successful in industry, I didn't need to borrow any money. I had a little money set aside, and I had a nice large garage.
Yeah. Yeah. Yeah.
I just started in that way, and it worked very
It was very well.
Yeah.
Congratulations.
Yeah.
You were a kind of a pioneer in switching mode
Yes.
power supply.
Yes.
Could you say what could you tell to our readers slash followers,
Yeah.
which in 2025 still rants about no linear power supply are always the best?
Well, the thing is, what people don't realize is that all power supplies create noise, even analog supplies, and the analog supplies that people are using often have no filtration, and no, you know, so any noise that is on the mains goes straight through their power supplies into their product. There are many advantages to a high frequency power supply, providing you know about the noise. You can design filtration that will totally make any noise disappear. With an analog supply that has no filtration, the noise can come straight from the mains all the way through,
Yeah.
and obviously that is a difficult thing, and really you're actually much better off with a well-designed high-frequency power supply than a normal analog power supply.
Did you use this type of power supply since the very beginning?
Since the very beginning. Yes.
Okay, that's very interesting. And can you tell us something in very easy terms to say something about the dual feed forward error correction technology? Is it
Yes.
something that you could explain easily to our follower?
There are various papers written in the 1980s, that were very interesting, and I decided to delve back into various papers, because most amplifiers, there are very few amplifier designs which are really modern.
Mhm.
They often go back
To the traditional schematics. Yeah.
Yeah. So I decided to look at. We were using just a standard sliding bias Class A/B design, and I wanted to improve the overall performance characteristics, and so I looked back at some work originally by a guy called Bob Cordell. Bob Cordell, and Malcolm Hawksford was the guy that originated the theory behind
The theory. Yeah.
And fundamentally, okay, with MOSFET devices, they have many good characteristics, but linearity is not one of them, because the depending on temperature and various other factors, their input characteristics change. So what the feed forward error correction does is that it basically it's like having a team of horses, each horse being a power device,
Okay.
but as well as you have a guy sitting on the coach with a whip,
Okay.
you have additional people riding each horse,
Okay.
and each horse is being gently controlled to give an overall pull of power.
Okay. 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 Okay.
So I mean, you know, that's one lousy analogy.
Okay. But it gave the idea.
Yeah, you know, basically, what we're doing is we're looking at the input to the FET and the output to the FET,
Yeah.
and therefore we're deriving an error signal, and then we're putting the inverse of that to the FET, but very, very fast. It has to be a very, very fast loop,
Okay.
and so you know, that really is what it's done. It just it enables the amplifier just to know more about its own status and to correct for
Correct.
that status.
Yes.
Yeah.
The last question is about the industrial design of your products. Are you in charge of the design of?
Yeah, I
Yes.
do all that.
And my question is, do you have any industrial designer which you like, or
Yeah, I think no, I
was an inspiration for you?
yeah, my original inspiration was someone like Anthony Gaudi. I don't know if you've
Yeah.
seen Pedera or any of his buildings.
Mhm.
Just the care and detail of that he goes into, and also the likes of Richard Rogers, who designed the
Rogers, yeah.
Pompidou Centre and the Lloyd's Building in London.
So I am an architect, so yeah, I was always
Also, Frank Lloyd Wright,
Yeah.
you know, with falling waters and,
Yeah.
and the way that the cantilever structures and things like that. So I would say, in general, I draw my influences, one from avionics, and that is form following function.
Yeah.
And also from great architecture. And I think I don't really draw my influences from any other products.
yeah.
So you know, it's original in that way.
And it's something that is immediately recognizable for me as an architect in your products.
Thank you. Thank
Yeah, absolutely. We tried the Ultima integrated amplifier,
you. Yeah.
and it was so beautiful when it's paired with
Yes.
Dave,
Yes.
which is its own bass.
Yeah.
The two was a perfect pair.
Thank you very
Very
much.
very nice. Very
I'm,
nice.
that's very heartwarming.
The last thing, if you want, obviously, to say hello to our followers in our YouTube channel, which is called Audio 2G.
Audio 2G, yes. Okay. Well, hello, I'm John Franks from Chord Electronics. I would just like to say thank you to Audio 2G to allow me to talk. I must apologize. I have a slight tickle in my throat at the moment. But I'm very happy to have the interview. Thank you very much.
Thank you. Thank you.
Thank you.